Good day everyone, we're excited to present our topic, evaluation of Forseq Kintelligence Kit and the Forensic Capture Enrichment Panel for Unidentified and Missing Persons caseworks based on a 2025 study evaluating two advanced DNA analysis kits, the Kintelligence kits and the Forseq panel. I'm Muhammad Hisham bin Muhammad Shahizan and I'll be joined by my teammates Muhammad Shazli Azmir bin Muhammad Shahrul bin Azman, Muhammad Zia Audin bin Zahari and Azam bin Cik Aziz for this session. Let's begin with the big picture. In forensic science, one of the toughest challenges is identifying unidentified human remains, especially when traditional short tandem repeat (STR) based DNA methods fall short. STR are limited to first and second degree kinship, but what if we could go beyond that? Introducing targeted amplicon sequencing or TAS, which uses single nucleotide polymorphisms, SNP, which are single letter differences in DNA, to reconstruct ancestry, physical traits, and even distant kinship. This piece of technological advancement makes the method ideal to identify unknown individuals directly by inferring ancestry and physical trait, mass disaster victim identification, and most importantly in the field of forensics is the ability to work with degraded DNA samples. This presentation highlights how SNP-based technology is advancing forensic identification and solving cold cases. Targeted amplicon sequencing or TAS employs massively parallel sequencing to read thousands of specific DNA regions at once. It works by amplifying target regions of DNA using PCR and sequencing them simultaneously. Each SNP is a single base change that gives us different types of information like IISNP, identify unique individuals. A key aspect of TAS is its ability to analyze single nucleotide polymorphism, small variation at single base in the DNA sequence. Different types of SNPs provide distinct types of forensic information. For example, identified informative SNP, IISNP, can distinguish between unique individuals, making them invaluable in identifying unknown persons. Other SNP categories serve different forensic roles. Phenotype informative SNPs, PISNPs, can predict visible traits such as hair or eye color. Ancestry informative SNP, AISNP, offer insights into a person's biogeographical origins, while kinship informative SNP, KISNP, help establish distant familial relationship. Additional, X and Y chromosome SNP are used to determine biological sex and trace paternal lineage. TAS combine these reconstructs identify profiles even when no close relative or antemortem records are available. This functionality represents a major advancement in forensic capabilities.
For this research, we intend to explore the innovations of this method as a sequencing method to add to a forensic investigator's repertoire in determining and analyzing kinship and generation in a certain individual. Thus, there are two types of SNPs that were developed in order to evaluate how well the innovative design of these SNPs are, which are known as Kintelligence and Forseq. Kintelligence, also known as the full name is Forseq Kintelligence Kit, while the Forseq is known as Forensic Capture Enrichment Panel. So the general method on how they use this is by using the TAS method. It was applied by extracting DNA and then preparing it into sequencing libraries and then running it through a MySeq FGX sequencer, where the raw data would then be analyzed by either Kintelligence or by Forseq, which both use different type of software in order to analyze the samples. So what's it used for? It's mainly used for identification of ancestry, physical traits, and also genetic relationships. So these are the comparison between the Kintelligence kit and the Force panel. So the Kintelligence kit you targets over 10,000 SNPs but only require 1 nanogram of DNA, while the Force panel uses a hybrid capture approach which targets over 5,500 SNPs but needs about 10 nanogram of DNA. While more DNA input is required for the Force panel, it offers expanded prediction including like skin tone and better ancestry resolution. So the Kintelligence also supports inbuilt analysis with by using the universal analysis software, which can help it in faster analysis. And while the Force uses the CLC genomic workbench and family too. So another thing is that since it has an inbuilt system, it also supports for Kintelligence. It also supports direct uploads to forensic genealogy site like CED match. But for Force panel, it's more suited for local identification efforts like disaster victim identification, like landslide and natural disasters like that, which involve a lot of unidentified victims.
Okay, now I will discuss on the workflow of Forensic Intelligence Kit. The first step is amplify. The Forensic Intelligence Kit utilizes a robust PCR amplicon base to amplify targeted SNPs. The second step is DNA extraction, where the DNA is carefully extracted, accurately quantified, and diluted to a minimum of 1 nanogram to meet input requirements. The third step is libraries preparation. The libraries are prepared manually, purified, barcoded, normalized, and also pooled to ensure consistency and high quality sequencing outcomes. And the last step is sequencing and analyze data, where the pooled libraries are sequenced using MISAC FJX system, and the resulting data is analyzed using universal analysis software. Next, the workflow of forensic capture enrichment panel. The first step is capture. The system uses a single primer extension approach with hybridization capture to specifically target the SNPs. Next, DNA extraction, where the DNA also is extracted, accurately quantified, and diluted to meet the required input amount with at least 10 nanogram recommended. The third step is libraries preparation, where the libraries are manually prepared, uniquely tagged with using molecular indices, enriched, amplified, normalized, and pooled to ensure high quality sequencing result. And the last step is sequencing and analyze data. The sequencing is conducted using the MISAC FJX sequencing system, and the data is processed and analyzed using advanced bioinformatic tools such as the CLC genomic workbench.
The Kintelligence kit offers exceptional SNP coverage, targeting over 10,000 genetic markers. This extensive panel provides vast capabilities for identification, kinship analysis, importantly investigate genetic genealogy, making it invaluable for solving complex cases. Another significant advantage is its sensitivity. The kit performs reliably with DNA inputs as low as 0.12 nanograms, a crucial feature when working with limited or degraded biological evidence. Force panel, while different in approach, bring its own strength. It delivers expanded genetic intelligence through specialized SNP markers that enable skin color prediction, higher resolution in biogeographical ancestry analysis, and Y chromosome halogroup determination. panel has been specifically optimized to work with separately declared samples, successfully targeting DNA fragments smaller than 75 base pairs, capabilities that make all the difference when dealing with challenging forensic evidence. The primary drawbacks are cost-related. The laboratory preparation process involves significantly higher expenses compared to the force panel. Additionally, while excellent for identification purposes, it doesn't include SNPs for skin color prediction, which limits its application in externally visible characteristic analysis. Force panel has different constraints. Its requirement of at least 10 nanogram of input DNA can be problematic when working with highly compromised samples. Perhaps more notably for investigative work, the profiles generated are not compatible with major genealogy databases like GEDmatchPro or Family Tree DNA. This limitation affects its immediate utility for investigative genetic genealogy, though the wealth of ancestry information it provides remains valuable for other investigative leads.
In conclusion, TAS technologies have advanced missing persons investigations by enabling identification without close family or antemortem samples. SMP genotypes aid in identification, predicting eye, hair and skin color (EVC), biogeographical ancestry (BGA), and kinship analysis. In this study, the Kintelligence kit outperformed the force panel QIAsec workflow for low DNA inputs, with force showing more adapted dimers and allele dropout, leading to poor coverage and non-concordant genotypes. Optimization of force workflow is needed for compromised samples. Lab must also consider cost, sample quality, bioinformatics, resources, and operational goals before adopting a TAS pipeline.